Good morning, everyone, and welcome to today's webinar. Electric vehicles are here. Are you ready? I'm Paul Wilkes, the FORS Business Services Manager, and I'm delighted to say that I'm joined today by Jeff Clark and James Nankivell from AECOM, who are a FORS champion. And as many of you will be aware, AECOM also manages the FORS concession, which means that you get to hear a bit more of me talking today with both my FORS and AECOM hats on. And this webinar is part of our monthly series, where we introduce you to one of our associates or champions who will share some of their knowledge and insights about best practice to help you to run your fleets, as well as some of the offers and discounts that are available to you. So before we go to the main presentation, I'll take this opportunity to remind you all about our associates. Now, FORS associates are companies who offer discounted products or services to FORS operators, and you can see here a list of the many types of areas that they cover, everything from kind of vehicle safety to telematics, fleet management to insurance, and so on. And you can find these offers and discounts from our more than 150 FORS associates by going to your members dashboard, and then you click on Browse Products and Offers, as you can see here on the right-hand side. And if you've missed any of our previous webinars, or you want to watch any of them again, then you can find a link to all of our webinars on our Knowledge Hub page, which you can find in the FORS webinar section of our training page on FORS Online. And we're going to cover a lot of information today, so we will be providing you all with a copy of the slides after the webinar as well, so you'll have those for reference. And so lastly, before we start the presentation, I just need to say that in the usual fashion, if you have any questions during the presentation, then please use the question chat box on the right-hand side of your screen, and we'll take some time at the end to answer any of your questions. Okay, so to introduce ourselves, these three handsome fellows here are myself, Paul Wilkes, Jeff Clark, and James Nankivell. And we all work for AECOM, as I said, which is a global infrastructure consultancy firm. And within AECOM, we're part of a dedicated freight team working on hundreds of freight, fleet, and logistics projects for both the private and public sectors. And we've also done a lot of work supporting clients to transition to electric and alternative fuel vehicles. Now, from the FORS standard perspective, there are a number of environmental requirements within the FORS standard, but there's no actual requirement to use electric alternative fuel vehicles. And as you can see here, there aren't any requirements at bronze, no requirements at silver, but at gold we do have the requirement G6 sustainable operations. And this includes a requirement to carry out a fleet review to consider the use of ultra low and zero emission vehicles. So what we're asking you to consider is the suitability of your operation for alternative fuel vehicles. And this may only be a requirement at gold, but we do know that members across all levels are already looking seriously at introducing EVs to their operations. And in fact, there are already 369 electric vehicles covered by FORS accreditation. And this is something that organisations of all levels could be doing. And so our webinar today will introduce you to some of the ideas that you should be thinking about when it comes to electric vehicles. So I'll now hand over to Jeff, who's going to start by talking to you about the market for electric vehicles. Over to you, Jeff.
Yes, thank you very much, Paul, and a very good morning to you all. It's good to be with you this morning. So we wanted to set the scene a little bit for electric vehicles and all of the thinking behind this and the decision making that you're all going through probably at this particular time, looking to what is your next vehicle purchase going to look like, and could it be electric vehicles? Well, let's see. So this particular slide here gives us an indication of different continents and the uptake of electric vehicles. So China has been leading the way for the last 10 years in terms of manufacturing development of electric vehicles, and they've got 10 manufacturers of EVs, and some of that technology has been coming across to Europe. But one of the things I just wanted to highlight is if you look in the Europe section there, in the last year, 2020, although as we know, it was a very difficult year for everyone, what's interesting is that actually the uptake of electric vehicle purchases in Europe And as you can see, reading across from the left-hand side, reached over 1 million vehicles sort of purchased across Europe, and that overtook the Chinese figure for the first time. And that rapid growth is something that we'll just have a look at in the next few minutes. And of course, importantly, if you look at the right-hand side, that's the percentage of electric car market share. And yes, I'm talking about mainly cars at the moment, and that's gone beyond the 10% for the very first time. Next slide, please. So leading the way in Europe, because the government of Norway is very sustainably minded and for many a year been reliant on electric power from hydroelectricity systems and things, but they've definitely been leading the way on how can we use electric transit. And in terms of the main factor I wanted to share with you, what's happening in Norway has some good lessons for us all. They're basically 5 years ahead of us in terms of take-up of electric vehicles. And indeed, fairly recently, they've announced that they'll be stopping the sale of petrol and diesel cars by 2025, which is 5 years sooner than our government has pledged to, which is obviously 2030. Interestingly enough, in 2020, sales of diesel cars and vans were down to below 10%. First time. Next slide, please. So in terms of the Europe and the truck and bus market, so there are increases across the board. So albeit starting from a very low level, but the number of electric vehicle truck registration was up 23% in Europe, 10% globally. Electric vans made up 2% of all van sales in 2020, and again that's up from 1.3% in 2019. And particularly in the UK, the electric bus market is showing a lot of interest, and across Europe that increased by 7% in 2020. And electrification is progressing fast in a lot of markets all across Europe. Next slide, please. So a number of manufacturers are putting a lot of money into the development of EVs across their whole range, and both Volvo, Tata and Daimler, of course Mercedes, are aiming for strong sales of electric vehicles. And indeed, as you can see from the top bullet point there, Volvo and that have pledged half of their sales to be zero emission by 2030, and looking at all new sales of vehicles for zero emissions by 2040, and similarly Daimler are aiming the same for by 2039. There's a lot of money in terms of commitment as well, in terms of the investment of a super fast charging network for heavy duty vehicles, i.e. haulage vehicles and long distance coaches. And indeed we're looking at a 750 kilowatt charger, which is the sort of charger that we'd need to try and top up batteries while drivers take one of their legal breaks of 45 minutes. And that's going to be quite a game changer when that comes in. Next slide, please. This particular one, again, showing an example of Volvo working with DFDS, well-known international transport company. And their range has already got 3 medium and heavy duty vehicles, which are looking to sell into Scandinavian countries, Switzerland, France, Germany, and Netherlands. And they've got 3 more models coming on stream next year. And they even go up to 44 tons now with the configuration. But of note, and James will cover this in a little bit later on, is the concern about the range that the current batteries have. But we'll cover a bit more about batteries and range. But nevertheless, things are changing in that field as well. Next slide, please. So 1/3 of global light commercial vehicle registrations in 2020 were actually in Europe. And this is not far from the China, which is the world leader. The demand for new electric vans alone grew 26% in 2020. And if you look just across the two neighbours, France and Germany, they accounted for over 60% of all the electric vans sold in Europe last year. But as far as the UK is concerned, quarter of 2021, the UK overtook France to become Europe's second largest market behind Germany for electric vans. And indeed, sales of battery electric vehicles almost doubled to 7% in the first quarter of this year. Next slide. There's a number of different companies emerging that are specialising in the design of electric vehicles, and they previously haven't been well known to us. There's a company called Reval in the UK, and this particular one is Volta Trucks, based in France, looking to introduce a new urban electric vehicle. And clearly the model they're designing is for an urban vehicle, and they're looking at having a package where you actually don't buy the vehicle, but you have it on a capital purchase system, which means you pay a monthly rental, which includes the power. And certainly they're targeting Paris and potentially London for the applications. Next slide. So as far as some UK fleets are concerned, thought you might be interested. The third largest commercial fleet in the UK is that owned by Centrica from British Gas, and they've got 12,000 vehicles, and they've dramatically made an announcement to bring forward their original commitment to electric vans to actually go all electric by 2025, and that's a full 5 years earlier than the British government view to stopping selling petrol and diesel cars. So a major commitment here. You probably know that British Gas are also one of the leaders in installing charge points as well, ranging from 3.5 to 350 kilowatt hours. And indeed, as far as the UK networks going, we're now in line with other European countries in terms of providing chargers. Next slide, please. So I'm going to show you a few examples now of sectors and different vehicles. So these are from the parcel sector, and just three examples from what is a very competitive market. Many of you will know that there's about 4.5 million vans on the roads of the UK, and that's been growing faster than any other type of traffic and vehicle type on the road. So here's three examples. DPD promises to operate an all-electric fleet in the UK by 2025. They're introducing electric vans, as you may have seen, in particularly cities where quality is an issue. Amazon, again, from not running some of their own vehicles a few years back, are investing a lot in running their own fleet, and have started introducing electric vehicles, not only in the UK, but across Europe. Indeed, there's a town in sort of Spain running about 60 of their electric vehicles already. And of course, over in America, they're obviously amassing quite a fleet of electric vehicles. DHL also looking to put on extra vehicles, not only this year, but next year in terms of EVs. Next slide, please. The medium rigid range is starting to be vehicles on the market, and there's a couple of examples to show you. This one, I don't know whether you read about it, but it's Warburtons are using this particular 16-ton Renault ZE in London, and it's got a 6-ton capacity. But importantly, not only does it qualify so it doesn't have to pay congestion charge or the ultra low emission zone charge, but also the package includes a 10-year guarantee on the battery, which is just going to show that there's more confidence now in the life of batteries, and many in practice are going longer than they originally expected. Next slide, please. So many local authorities are looking to make the change away from diesel. Certainly they're doing that in the smaller end, and there are increasingly examples on the market of not only electric vehicles, which is of course the subject of today's talk, but also there are other options potentially of hydrogen that we'll discuss perhaps in future months. But for today, I wanted to highlight York City Council's recent purchase of 2 narrow rubbish collection vehicles, and these travel about 80 miles a day, doing a 12-hour shift. And apart from being well liked by the drivers and crew because they run all electric, and indeed the operating system at the back is all electric as well, but they're really quiet as well, and actually don't make so much noise outside the houses when they come and collect the refuse from 7 AM onwards. Next slide, please. In terms of timelines then, across here, obviously the legislation is catching up with where we need to be. So homes are now being installed with charge points. We've also got the start of clean air zones in many cities, which is of course prompting many of us to think about changing to an electric or a zero emission vehicle. And we've got both Birmingham and Bath have already introduced clean air zones earlier this year, to be followed by other cities like Bradford and Manchester next year. And of course, not only do you avoid having to pay the penalty charge for going in with a non-compliant vehicle, but also there are certain available retrofits as well to some of your older diesel vehicles, actually to become compliant with Euro 6. So at the moment, the clean air zone does allow you to enter with a Euro 6, just for note. 2030, already well known, the government plan to end the sale of new diesel petrol cars. By 2035, bans to be zero emission, and at the moment there's consultation on but expected to end the sale of new diesel HGVs by 2040. Next slide, please. There was a survey done about a year ago by the Society of Motor Manufacturers and Traders, and it was interesting that around 44% of UK motorists believe that 2035 is too soon for the switch to electric. And I think part of what was driving that was concern over the high purchase prices and the perceived lack of charging infrastructure that consumers are saying. Having said that, though, as James will explain in a few minutes, there's quite a network of electricity charging points building up, and we'll talk about that soon. But nevertheless, the SMMT urged the government to introduce incentives, longer-term incentives for EV purchase to try and help with the affordability of them. But at the same time, on the positive side, 37% of motorists remained optimistic about purchasing a new EV by 2025. And certainly, if you look at any of the things like Auto Express or looking at van trading markets and that, most manufacturers now have good and interesting EV models to be able to look at. Okay, that's what I want to cover about the market. And I'll hand over to James, who will talk about the problems and issues that you may be encountering when considering adopting EVs. So over to you, James.
Thanks, Jeff. So I'm James. I work for the FORS programme, and as Paul mentioned, I also work for AECOM's freight team. I'm going to run through the problems and issues associated with adopting EVs, the different types of chargers available and charging speeds, the benefits of EVs, and then I'll finish on a couple of case studies which detail how AECOM have been assisting companies such as yourselves with their transition to ULEVs, and the types of things you should be considering when implementing your own transition. So you can see a number of problems and issues there. I'm going to run through these now in greater detail. So we just go on to the next slide, please. In terms of availability then, so the range of available models, it's limited, particularly with HGVs. Although, as we've heard earlier in the presentation, the major truck manufacturers are really making headway into bringing new models to the market. COVID's also created a shortage of semiconductor microchips, and this has disrupted supply on certain models and restricted the automotive recovery. In terms of changes to process, so we found that existing staff scheduling and shift patterns, they don't accommodate the charging of the vehicles. and certain company policies, such as the health and safety policies, have become outdated. Next slide. In terms of fitness for purpose then, so we've got range anxiety. So it's perceived that EVs are unable to meet daily fleet mileage requirements. And there's also having these heavy batteries on board can actually reduce the payloads, meaning that the profits are affected. In terms of charging infrastructure, so there's concerns that the public charging infrastructure isn't in place to meet demand. And there are several major infrastructure projects taking place, but it's going to be a while before those charges are as common as filling stations. There's those, you know, the charge points that are available. They can potentially be impractical for HGVs due to bay sizes, power requirements, constraints with drivers' hours. So the capacity that they actually offer may not be enough to actually charge the vehicle in a timely fashion. Just go on the next slide, please. In terms of maintenance then, so although the batteries tend to have a long lifespan, they don't last forever. So replacing one of these could be perceived as a major expense. In-house maintenance, it may require either hiring new technicians who are knowledgeable about electric trucks or vans, or training existing employees in EV upkeep. In terms of that training, so as with any new vehicles, technology and kit, the training of staff will be required in their operation and use to ensure a smooth transition. And that training, it's not just for the drivers, it's also for fleet managers. So it's about them being able to give a level of confidence to you know, their drivers whilst they're on the road. Having a lack of training, it can be could result in costly and disruptive setbacks. Next slide, please. So I'm just going to talk about sort of an overview of charging types and speeds. So the electric vehicle market is continuously developing, and this slide provides a general overview of the current charges and typical rate of charge, which can be achieved by each of the charger types. So charge times, they'll depend on the size of the battery and the amount of the vehicle battery as discharged. And these figures, they show you know, they give a rough indication, but these times will vary from vehicle to vehicle. It can also be affected by smart charging and things like ambient air temperature. In terms of the main charging speed categories, so you can see there we've got slow, which is around about the 3 kilowatt output, and these are ideal for residential charging and for applications where there are vehicle dwell times in excess of 10 hours. We've got fast charging, which is typically between 7.4 kilowatts to 22 kilowatts. These are typically found in long-term parking and workplace parking. We've got rapid, which is 45 to 50 kilowatts. These are typically used for medium to large vehicles and for ad hoc charging of smaller vehicles. And then we've got ultra rapid, which is 100 kilowatts plus. And these are generally for larger vehicles with high capacity batteries. You'll notice a couple of green circles on the slides there. The first one, vehicle to grid. So this offers the opportunity to reduce energy demand and carbon emissions by using the energy stored in the EV to feed back into the grid or the depot buildings. And then smart charging. So this provides a versatile way of charging individual vehicles, and it helps to reduce stress on the electricity supply. It can help you take advantage of reduced tariffs, provide a more battery-friendly approach to charging, as well as remote control of charging. Next slide. So this slide, you can see a number of benefits to EV adoption. So essentially, we're going to look at why you should adopt EVs. So I'll go through these briefly. I won't touch on all the points, but you know, EVs are better for the environment. So they emit fewer greenhouse gases and air pollutants, and so they improve air quality in towns and cities. They help to reduce noise pollution, which creates a more peaceful environment for us all. They can help with your corporate social responsibility. they can be cheaper in terms of fuel when compared to comparable ICE vehicles. So if we look at the Nissan EV, the NV200 as an example, and if we say that the average UK electricity price is around 16p a kilowatt, the cost to charge it at a home depot would be around £6.40 at a cost of 5.4p a mile. When you compare that to the ICE equivalent, you know, you'd find a cost of around about 12p a mile, and that's if fuel cost was about 1.34 per litre, which it currently is, and we assume an average fuel consumption of around 49 miles a gallon. Obviously, these calculations are rough. They're designed to give you a rough indication, and costs will be dependent on where you live, the prices you pay for electricity and fuel, and the vehicle you own and where you charge it, so whether that's at home or public charging. And they could be cheaper to maintain. So fully electric vehicles are currently VED road tax exempt. There's also benefit in kind to factor in. So at the start of 2020-2021 tax period, the government actually lowered the benefit in kind tax rate for electric vehicles from 16% to 0%. So there could actually be never a better time to own an EV. There's no congestion zone charges attached to operating EVs. And from a work winning perspective, clients may look more favourably on a company that shares its own greener operating practices. Next slide, please. So we've got a couple of case studies here. So this is provides an overview of where AECOM have worked with companies such as yourselves. So this first example, it's for a mixed car and van fleet. So the client was pursuing the following policy-related targets, which you can see on the slide. So they wanted to convert 25% of their 1,200 mixed car and van fleet to ultra-low emission vehicles by March 2022. And they also wanted to ensure that all new car purchases were ultra-low emission by default, and you know, basically achieving 100% ultra-low emission car and van fleet by 2030. Next slide. So this slide highlights a number of real-world issues that the client encountered. So the client highlighted several constraints related to charge point infrastructure, which we helped them overcome. So the first was to do with range anxiety due to the lack of awareness of available charge points. There was the issue surrounding company policy position on home charge point availability. The company felt that a one-size-fits-all charging infrastructure solution was unlikely due to company operations and vehicle requirements. And when I say that, I mean this particular fleet operated a wide range of vehicle types and sizes. Some vehicles carried equipment, some were used as mobile offices, and some didn't even return to the depot on a regular basis. So we had to overcome this issue with them as well. There was changes in working practices, you know, with regards to accommodating vehicle charge time requirements as well. Next slide, please. So this slide here, it provides an overview of the two streams of work that we conducted with this client. So the first one was to produce a business case. So AECOM themselves conducted a fleet review of the current U11 charge point market, along with a full fleet review of the client's 1,200 vehicle fleet. Our team undertook stakeholder engagement with the client's fleet team to identify and understand the fleet's current character and composition, and that included how the vehicle fleet was operated and how the vehicles were procured. That then fed into recommendations development, where we then made these recommendations on how the fleet could be adapted to achieve the ULEV targets, and this led to the formulation of a strategic transition plan, where we made recommendations for next steps and actions, and we did that over the short, medium and long terms. The fleet transition strategy itself, so this involved us analysing existing fleet and staff scheduling data. We conducted gap analysis to identify further information needed. We conducted primary data collection in the form of stakeholder engagement with key managers, and we did an electronic survey of staff as well. So all this fed into us determining which staff were suitable for transition from the current vehicle that they operated. And then we also revised the reporting system. So we actually produced an initial list of key performance indicators upon which to determine the success of the transition. So the transition strategy as well. So this included a phased approach to vehicle conversion by vehicle type and numbers. We also produced educational information about ULEVs relating to key issues such as benefit in kind, the running costs, the performance of the vehicles and the range. And we also conducted a communications plan to promote the use of ULEVs within the organisation itself. Next slide. So this is a second case study. So this was a car, van and HGV fleet. So the task here, so we were actually commissioned by a client to undertake the design of their new depot facility. And the commission included several carbon reduction measures such as comprehensive solar panel coverage on the depot roof and multi-storey car park roof. It included future-proofing for hydrogen refuelling. And the work itself, it involved the production of the depot electrification strategy, which involved how the electrification of the depot should be undertaken. And we also factored in the changing needs of the fleet operating from the depot in the coming years. So in addition, you know, the production of the guidance for future fleet transformation was conducted, and guidance to future-proof the design for the future investment in the fleet transformation was also done as well. We also recognised the change in horizon in alternative fuels. So we incorporated, like I say, you know, hydrogen into that model as well. And all this was done over short, medium and long-term periods. Next slide. So a number of issues were encountered. So again, these are real-world issues. So the company highlighted several concerns with transitioning to alternative fuels. And these included uncertainty into how quickly the transition would take place, the type and range of vehicles currently operated and their fit with the different sort of fueling options. There was a reluctance to act too soon, particularly as the battery and charge technology was developing so fast. There was the whole Betamax versus VHS, so hydrogen versus electric for the HGVs. There was a reluctance to have an all-electric fleet in case of power loss. So, you know, they didn't want to be left with a fleet that was inoperable when the grid went down, for instance. There was the current vehicle replacement cycles to be taken into account, and there was unknown future service demands. Next slide. So initially then we undertook a fleet review to determine what the composition of the current fleet was and how it was operating on a daily basis. And then we conducted research to see what alternatively fueled vehicles were currently available that matched the client's fleet profile. So the findings we used to develop a short-term fleet transition strategy, and that was based on ULEV availability in market, level of organisational impact, client operational functions and general ULEV technical constraints around range and charging time. So where there were no suitable alternatives available, we suggested a number of different fueling options that the client could adapt in the interim until these vehicles became available. We provided insight into charge capacity, charger types and smart charging capability requirements. And we also provided guidance about how to maximise vehicle range and reduce the amount of time the vehicles needed to charge and reduce battery degradation. Can you just flip to the next slide, please? So this is the overview of how we help the client achieve their objectives. I've covered a few of the the first ones there on that slide. But we also created a phased approach to vehicle conversion by suitable vehicle type and numbers from 2021 to 2035. And we also developed an ongoing monitoring plan which incorporated activities such as the measurement of fuel efficiency, analysis of telematics data, user experience, and overall life cycle cost analysis. Next slide. So in terms of government funding then, so this slide highlights what funding is available to the people on the call. And so from the truck perspective then, you can see a number of criteria that needs to be met in order to gain access to this funding. The grant, it'll cover 20% of the purchase price. There's 10 grants available per customer, and it'll cover up to about 16,000 maximum. Next slide. In terms of small vans and large vans then, so again, there's an overview here of the different criteria that needs to be met to be able to apply for this funding. All the main constructors are covered. You know, you've got the likes of Citroën, Renault, Peugeot, and for small vans, it's going to cover about 35% of purchase price up to a maximum of 3K. And for large vans, it'll cover 35% of purchase price up to 6,000 maximum. There is also a grant for vehicle charges, and that's up to £350, including VAT, off the cost of installing a charger at home. And there's a link there that you can access if you like. Next slide, please. So there's a number of other useful sources of information here. So I recommend you, you know, click on each of these links and get more information if you are thinking about transitioning to EVs. The government website, it details everything you need to know about the grants and also the transition to EVs. Energy Saving Trust, CMO Partnership and Energy Task Force, they've got loads of really useful information on there that you can access. There's lots of webinars you can attend to help you with the process. You know, there's lots of good stuff there that you can access. I've also detailed Zap Map there, so that those that aren't familiar with it, this is an app that you can download, and it gives you details of where charge points are in the country. So it's a really useful tool to use, and you know, give it to your drivers, and they'll be able to locate charge points nearby. Okay, next slide. I'll talk about this briefly. We're going to leave this up on the slide pack while we have a discussion. So this is our offer, really. So AECOM can help your company to conduct a fleet review, produce educational material that you can give out to individuals in your organisation. We can help you with ongoing monitoring, so whether that's KPI design or policy review, we can help you with that. We can help you with your communications strategy and planning, produce the electrification strategy, and we can also help you with your fleet transition and planning. And that's it, thanks.
Thanks, James. Okay, so just a reminder, we have got quite a few questions in the chat already, but if you do have any other questions for us, then please raise them in the chat box, and we will try and address those. So just to pick up on some of the questions that we've got. Right, this one's for Jeff to start with. I think it was in relation to some of your slides. Do the distant ranges that you'd given include equipment operations like PTO or tipper bodies?
Yes, well, certainly as far as the City of York waste vehicle, for example, one of the biggest draws back on that is actually the bin lift equipment and that sort of thing. And the equipment obviously is a PTO takeoff. So the whole point with that operation is that the overnight charge is more than adequate for the full day's work. And clearly the stop-start in the City of York is a lot, because there's quite a lot of urban dwellings and also boxer flats and things like that. So in that application, that's absolutely fine. But I do agree with you that you do have to take on board the fact that the electric batteries do have to supply all the ancillary equipment for the vehicles, which obviously has an effect. But I think some of the information we've seen about the trials of EVs, for example, for bad weather and things like that, are suggesting that some of the draws back on the battery, let's say a bad February day with sort of very heavy rain and very dark, isn't necessarily drawing quite as much as some of us feared, actually. So, so I think that's worth looking into, but you must factor in that sort of extra contingency. Yeah.
Thanks, Jeff. And second question, what's been done for the construction-based haulage? Are you aware of any electric vehicles out there, particularly aimed at the construction market?
Okay, I would say at the moment, the development of, for example, I'm minded to say, don't forget there's lots of manufacturers in the market, but the slide I showed was Volvo with their FM range. And when I was a transport manager, I used to have Volvo FMs in the tipper market. So very similar to the presumably who's asked the question. Now, I would say those sort of vehicles in that market are likely to be out pretty soon. And again, the point there is a lot of tippers are used on fairly short distance runs between the construction site and, say, a demolition site or something like that. So actually, range might not be a problem. So potentially electric vehicles for parts of the construction industry might be quite suitable. But again, I think you need to make sure you think about the full capability of the vehicle fleet, because it might be that another contract you actually do highway maintenance and you might run longer distances. So actually making sure of that range, I think, is a really important thing to do.
Thank you. And got a question about whether it's actually disingenuous to refer to these vehicles as zero emission when they emit just as much black carbon from brakes and tyres as conventional vehicles.
Yes, and
a bit more.
Yeah, that's right. And quite right. You know, I think we do accept that the particulate matter from tyre wear, obviously brake wear is there's different coefficients of that, because obviously part of the braking system is obviously regenerative braking back into the power. But I do accept that there will still be pollutants from those sorts of things, and I think we probably, if that's what I said, I think we fall into the trap of talking about that. We're talking about the traction of the vehicle forward is going zero rather than the full capability of the vehicle. And of course, the same trap is also there because a lot of electricity produced has been made at the moment by gas. And we've all seen some of the main media today about energy prices rising and things like that. So potentially, I've even heard about some of the coal-fired power stations having to come back online because coal is now cheaper than gas potentially. So all of that, yes, you're right. We need to recognise the full implications of all that we're doing.
No, thank you. And that nicely leads on to the next question, which are around kind of charging. Does the charging rate that you use for the vehicle impact the battery life? So if you're going for faster charging, does that degrade the battery quicker?
Yes, yeah, I think there's some talk on that, and I'll pass over to James in a minute. And I think you need to look at the applications that you're wanting, and many companies are looking at not necessarily charging right fully and doing partial charging and that sort of thing. And also some companies are saying we don't actually need to charge every day. Certainly running small vans or something, you might have enough charge in the vehicle to last you all week and that sort of thing. But again, can affect battery life and things. So James, you're perhaps more technical than I am on battery life. Do you want to comment on that?
Yeah, so yeah, battery degradation, then it can be affected by the type of charge sessions. So it's advisable that you limit the amount of rapid charge sessions. I mean, Geotab, for instance, have found that the use of DC rapid charges, so when we say rapid, we typically mean 50 kilowatts and above, appears to increase the rate that batteries degrade. So after 48 months, EVs operate in a hot climate, for instance, which have been rapid charged more than 3 times a month, would have an average battery state of health of around 80%. After the same period, an EV which had never been rapid charged had their state of health of around 90%. So in terms of you know, the use of rapid charging, then it can impact the degradation of the batteries.
Thanks, James. And there's a question about will the power grids have the capability to keep up with the future demand of all these vehicles charging at once?
It's the million-dollar question, isn't it? You know, there are things that you can do to help alleviate the demand on the grid. So the example we gave where we worked with one of the clients was they were actually using solar panels on their depots to draw that electricity from to charge the vehicles. There's also vehicle to grid, which you could you know, look at. And in that instance, when the vehicles aren't being used, the batteries actually feed back into the depot and help to alleviate that demand as well.
Yeah, also to add to that, James, I think some companies, I mean, I gave the example of Amazon there, they're investing in solar power themselves. And there's various others. I was hearing about a bus company that's also invested in solar panels and is having a big battery pack on the site as if you like a stopgap measure for short-term peaks and that sort of thing, so that they can top up when power prices are low and then sort of help to use that as part of it. And of course, I think that does help you get over a short-term issue, but there are also some energy companies coming on the market now that are looking to work in conjunction with the grid and actually have major battery and major energy refueling points, where that does rely on having big batteries at the same point. And some of them are again looking at solar and other means of sustainable power to top up those batteries.
Yeah, and the other thing as well to mention, Jeff, is that you know there needs to be sort of a policy in place really to say that. So, for instance, ChargePoint, they say that when using charging, it's best to unplug when the battery reaches about 80% charge. So, you know, every battery follows a charging curve when plugged in. Charging starts slowly when the vehicle monitors several factors from the battery's charge level, you know, from the weather outside. So it's important really to you know, only plug the vehicles in when you need to. There could be a tendency to plug these things in all the time, and that'll add to the drain on the grid as well.
Excellent, thank you. And in your slides, when you talked about the second case study, you mentioned interim fuels and measures.
Yeah.
Can you talk a bit more about what interim fuels and measures you used within that?
Yeah, of course. Yeah, so we looked at other alternative fuels. So we looked at HVO, we looked at gas. You know, other sort of alternative fuels that could be adopted for the heavy fleet, essentially. So we know that perhaps, should we say, the technology is lacking for the heavy vehicles at the moment. So in order to bridge that gap until you know, EVs come on board or hydrogen comes on board, we suggest that, you know, you could adopt a model that the likes of Asda and Waitrose are using, in that they're running the vehicles on gas and HVO, which require less adaptation to the vehicles themselves.
And how successful was the HVO gas?
Yeah, it's good. Yeah. Feedback we've had is it's good. Like I say, there's very little you need to do to be able to run your vehicle on HVO. You just pump it into the vehicle and you're good to go.
Yeah, I think Paul just added to that. So it's hydrotreated vegetable oil we're talking about, and it's a direct replacement for diesel. And so you can just go in your diesel tank. There is a premium price to pay for it, but actually the reason for thinking about it is that actually the claim is that you can get 85 to 90% saving on greenhouse gas. And that's a major thing that companies would like to see and be able to declare on their boardroom stats, that we've made a major difference in terms of climate change. One thing to note, though, with using something like HVO is that it doesn't sort out the local air pollution bit, so there is still pollutants coming out of the tailpipe.
Okay, thanks, Jeff. That's very helpful. And another question on how can we get a grant for installing chargers at the office?
That's a good question. It's something that I can answer at a later date. And by all means, I can send you some information about grants for charging it at the offices. I haven't got that information to hand now, unless Jeff, you've got something on that. But certainly we can come back to you with more information. Yeah.
Okay. And from a van perspective, they're saying the highest range they're coming across currently is between 90 and 110 miles before a charge is needed. Is there anything higher in that space for vans at the moment? Are you seeing anything higher than 110 in terms of range before?
Yes, I think the figure you're giving is about the sort of figure we were looking at. If you like, we can send out with the pack something from Auto Express that they've done a review of electric vans recently, and from their 2021 review, 121 miles is their sort of range. They're saying is the average at the moment. When you balance that against the DFT research into the use of vans, it's interesting that on average, we're only using a van for about 12,800 miles a year, which, taking a normal Monday to Friday working average, is around about 49 miles a day. So that's an average van. So when you think about it and think about that range, for the vast majority of fleets, that actually EV is the current range is perfectly okay. But I think there's the later generation of vans coming out now with extra batteries on, and of course there are vans where you can actually specify longer range batteries as part of the options on them. So it's worth looking at that as well.
Yeah, so don't quote me on it, but I think models like the Citroen e-Dispatch, I think the Vivaro E have been quoted as having range of up to 200 miles, and also the E-Relay, Citroen E-Relay, and Peugeot E-Boxer. I think they've been quoted of having ranges up to I think it's 170 miles as well, so a bit further.
Yeah, I guess it depends on how it's loaded as well.
Yeah,
the duty cycles of that.
Yeah.
Cool. Thank you. And do any electric vehicles above 3.5 ton require a PMI, even if not governed by the tachograph system? They're currently looking at vehicles that have a gross weight of 4.2. Would that need a PMI, a regular PMI in the same way?
Yeah, good question. Certainly, I mean, obviously, there's a derogation, isn't there, for the weight of batteries onto things. So, for example, derogation on, I think, 19-ton for the 18-tonner is being talked about, and 27-ton for a 26-ton bridge is being talked about. In terms of PMI, I don't know whether, James, you've got the precise answer on that one, but it seems logical that there would be.
Okay, thank you.
Yep.
And is there an estimate length of time a battery will last in a vehicle, and can they be rebuilt and reused, or are they just disposed of? So is there reusable technology within that?
Well, I think the battery life is getting better on the later generations of batteries. So I think, 3 years ago, people were talking about 5 years, that sort of thing. Now, generally talking about an 8-year battery life. And as you saw on the slide I showed with that, the Renault truck from Warburton's, they're underwriting a 10-year life for the battery. Now, clearly, obviously, there's concerns about the trace elements and how you dispose of the battery, and with sort of lithium ions and things like that being increasingly in demand for all of the batteries. But I would say that a lot of people that have been using electric vehicles have been pleasantly surprised by the life they've actually managed to get out of their, say, second generation batteries. And of course, we're now into third generation battery development and use now. So I think overall there is concern about how they're disposed of. Yes, I don't have any good answers for that on this call, but certainly as battery technology improves and new factories come online to make the next generation batteries, we can expect that to get better.
Yeah, so the whole reusing and recycling of batteries, it is a growing market, as Jeff says, and there has been a lot of research into the use of second-hand batteries, and looking at ways to reuse those batteries in new technologies. That could include electricity storage. We've been working with a few councils on exploring that option. It might be that one day we've all got batteries in our homes being used to store our own energy. So all these sort of options give a second life to the batteries, really. We've also been working with bus fleets as well. So typically with that vehicle segment, the life cycle tends to be fairly long. So looking at 15 years. And the idea is that you change the batteries at around 8 years, depending on how they're performing, and then conduct a refit of the vehicle itself to extend the life.
Thank you. Okay, there's still quite a few questions left to go through. So what I think we'll do is we'll pick off some of these separately and come back to you individually after the webinar. But there's just one I wanted to finish on was, how is the issue of charging company vans at an employee's house and repaying for electricity overcome? Is that something we have addressed through any of those case studies?
Yeah. So we've helped organisations, with that issue. Obviously, it can be quite difficult sometimes to determine how much electricity has been drawn from that person's home. So we've put a number of processes in place to be able to better monitor that and feed that into the business sort of expense model.
Excellent. Thanks, James. Okay, so as I said, apologies if we haven't got to your question, but we will come back to you after the webinar. So that just brings it for me to conclude our webinar for today. Hopefully you found it all useful and informative. It certainly was for me. So I'd just like to say thank you to Jeff and James and all the team behind the scenes, and all of the audience today for joining in and asking lots of good questions. Keep an eye out for our next webinar, which is going to take place in October, and we'll be publishing details about this very shortly. Now, at the end of the webinar, you'll automatically receive a feedback survey, and I would ask that you spend a couple of minutes giving us your feedback, as we do use your comments to improve future events. And this was one of the suggestions from a previous webinar of topics that you wanted covered. So this was in response to that. So please keep coming with your suggestions. So that's it from all of us. Thank you all for your time this morning, and goodbye.
Thanks out.